All right, welcome back. We are on day 7 of our ACT Prep Unit 4, which is Intermediate Algebra Topics. And today we're going to talk about complex numbers. All right, you'll most frequently encounter complex numbers as you solve quadratic equation. Imaginary numbers. We call the square root of -1 an imaginary number because it's not real. There's nothing times itself that would equal a -1. It's neither a whole number, a decimal, nor a rational number. We use the symbol I to represent this imaginary number. So anytime you have the square root of -1, you replace it with I. The square of I is -1. So anytime you get an I squared, it turns into a real -1. It's kind of like Pinocchio. Pinocchio wanted to be a real boy. Well, I doesn't like being imaginary. Nobody likes being imaginary. Okay, so anytime I can get squared, then it turns into a real -1. So for example, if I have 24I squared, that's really 24 times -1, which equals -24. Okay, and then standard form, every complex number has a standard form, a plus bi, where a and b are real numbers. All right, so complex addition. Treat I as a variable when you add complex number. Let's look at these examples. If I have a plus bi plus c plus di, they're telling you to add this complex number to this complex number. Well, it's just like terms. This is the real part, and this is the imaginary part of the first complex number. The second complex number, c is the real part, and di is the imaginary part. Really, what you do, though, is you just treat it like any other problem, and you follow PEMDAS. All right, there's nothing to distribute here, so that stays a plus bi. You're just distributing the positive. You're not distributing, you're not multiplying these complex numbers. You're adding these complex numbers. So I'm adding a c and I'm adding a di. And then what you do is you combine like terms. You combine your real with your real. Oops, I don't like that color. So that would be a plus c. And you combine your imaginary with your imaginary. That would be plus bi plus di. And that's as much as I can do. I mean, they'll write it like this. They'll say a plus c plus I times b plus d. This and this mean the same thing. They just factored out the I there. Okay, so for two not real complex numbers, but for two complex numbers that are not just variables, again, you do the same thing. This would be 3 plus 4i. You're adding this second complex number, so you're adding a 5 and you're adding a 6i. Then you combine like terms. So I can combine my real with my real. 3 plus 5 is 8. And I can combine my imaginary with my imaginary. 4 i's plus 6 i's make 10 i's. And that would be my final answer. Okay? All right, so complex multiplication, you still treat I like a variable, but remember that anytime you get I squared, it turns into a real -1. Now we're not adding, we're multiplying. These walls are touching, so now it's basically FOIL. A times c would be ac. A times di would be positive ADI. And then bi crawls times c is positive CBI. And then positive bi times positive di would be positive BDI squared. And then how you simplify this is, I don't know if you wanted to pull the i's out, you'd have AC plus I times AD plus CB plus BD times -1, which makes AC plus I times AD plus CB minus BD. Okay, that would be that simplified. When we talk about some examples that don't just have variables in them, okay, 3 times 5 would be 15. 3 times positive 6i would be positive 18i. Then we distribute the positive 4i times 5 is positive 20i. And positive 4i times positive 6i is positive 24i squared. So now we clean it up. We combine like terms and replace I squared. So I have 15 plus 38i plus 24 times negative 1, because I squared turns into a real negative 1. Distribute, and I get a negative 24, and the rest comes down. And then finally I can combine the 15 minus 24, and I get negative 9 plus 38i. And that would be my solution. Okay? Complex division, it says the expression 3 plus 2i divided by 1 plus I can be written as 3 minus 2i over 1 plus I. However, this is not a complex number in the form a plus bi. We can simplify the fraction. We can't actually divide by I. It's illegal. You can't do it. So when you're told to do complex division, you don't really do any division. What you do is you rationalize the denominator, which basically means you got to get rid of the I in the bottom. Okay, and we do that by multiplying by the complex conjugate of the denominator. The complex conjugate of a complex number a plus bi would be a minus bi. You only change the sign in the middle. So and if I look at these examples, I can't divide this, but I have to rationalize it. I can't leave an I in the denominator. So the rule says you multiply the top and the bottom by the conjugate of the bottom, because conjugates kill i's. The conjugate of 1 plus I would be 1 minus I. But if I do it on the bottom, I have to do it on the top. So on top, I'm going to have 3 plus 1 is 3. 3 times a negative I is negative 3i. Negative 2i times 1 is negative 2i. Negative 2i times negative I is negative 2i squared. Clean it up, combine i's, and change I squared. I get 3 minus 5i minus 2 times negative 1. Cleaning that up, you get 3 minus 5i plus 2. Combine like terms, and I get 5 minus 5i on top. Okay? So then I have to simplify the bottom. 1 times 1 is 1. 1 times negative I is negative I. Positive I times 1 is positive I. Positive I times negative I is negative I squared. And look what happens. And this always happens when you multiply conjugates with complex numbers. The 2 i's in the middle will always cancel. They have to, because these are opposite signs. Oops. Those are opposite signs. Alright? And then so I have 1 minus, and then this turns into a negative 1, which gives me 1 plus 1, which gives me 2 on the bottom. And this would be my solution. Okay, there's no more i's in the denominator, so we're good. Alright, this one over here, again, I can't divide by I, so we're going to multiply the top and the bottom by the conjugate of the bottom. The conjugate of 2 minus 6i is going to be 2 plus 6i. So again, on top, I have 3 times 2 is 6. 3 times 6i is 18i. Negative 4i times 2 is negative 8i. And negative 4i times positive 6i is negative 24i squared. Combine i's and change I squared. I get 6 plus 10i minus 24 times negative 1. Distribute. I get 6 plus 10i plus 24. Combine like terms, I get 30 plus 10i. So there's my top. Okay, on bottom, okay, I'm going to have 2 times 2. 2 times 2 is 4. 2 times positive 6i is positive 12i. Negative 6i, sorry, let me change colors. Negative 6i times 2 would be negative 12i. Negative 6i times positive 6i would be negative 36i squared. Combine i's and change I squared. And these were conjugates, so just like before, the middles will cancel. That gives me 4 minus 36 times negative 1, which gives me 4 plus 36, which gives me 40 on the bottom. And that's my answer, except for the 30, the 10, and the 40 can all be reduced by 10. 10 goes into 33, 10 goes into 10 once, 10 goes into 44. So my answer is 3 plus I over 4. That would be my simplified or my reduced answer. Okay? Alright, you try this one. Hit pause, come back when you're ready. And hopefully you got B. Alright, this is just, you're just writing it in standard form. So you're trying to make it look like A plus BI, which means combine like terms. 3 minus 7 is negative 4. 4i plus 5i is positive 9i. And we're done. Try this one, hit pause, come back when you're ready. And hopefully you got J. Alright, they're wanting me to multiply these two complex numbers. So 6 times 5 is 30. 6 times 2i is 12i. Negative 4i times 5 is negative 20i. Negative 4i times positive 2i is negative 8i squared. Combine i's and replace I squared. I get 30 minus 8i minus 8 times negative 1. Distribute, I get 30 minus 8i plus 8. Combine like terms, I get 38 minus 8i. Okay? Alright. Did I skip something? Alright, so yeah. Alright, they just wanted me to practice. Alright, so when you have, anytime you see an I squared, you can replace that with negative 1, which makes this negative 18. I cubed, the trick here is when you have bigger powers of I, is to find out how many I squareds there are. This can be written as I squared times I, that's still I cubed. Well, this is negative 1 times I, makes it negative I. Okay? 3, anytime you have a negative under an even radical, it comes out as I. So the square root of, this is like I square roots of 49. And the square root of 49 is 7, so my answer would be 7i. This 4 is going to be I square roots of 50. Now 50 isn't a perfect square, but I can break it down. By 2 is 25, by 5 is 5. So there's my perfect 25. The square root of 25 is 5. I mean, I guess I should write it like I used to. I could write that as this 50 is the square root of 2 times the square root of 5 squared. Okay, that's I. That has to stay. That's not perfect, but the square root of 5 squared is 5. So my answer is 5i square roots of 2. Okay, on 5, this is I square roots of 48. And again, I need to break down 48. So 48 by 2 is 24, by 2 is 12, by 2 is 6, by 2 is 3. So I can rewrite 48 as the square root of 2 squared, the square root of 2 squared, and the square root of 3. And then I can simplify those perfect squares. That's 2, and that's 2. So I have I times 2 times 2, which is 4i square roots of 3. Okay? Alright, they want me to write these in standard form. Well, combine like terms, 18 minus 6 is 12 plus 5i. Done. Alright, multiply first, that's 27 plus 3i. That's standard form. Combine i's here, you have negative 16, 4i minus 5i is negative 1i. Combine real to real, I to I, you got 8 plus 12i. This, you're going to have 7 times 6 minus I square roots of 1. Square root of 1 is 1, so you really have 7 times 6 minus I. distribute the 7, and I get 42 minus 7i. Okay? Alright, 11 they want me to add. So I'm taking 2 plus 9i, and I'm adding the 3, and I'm adding the 7i. Combine like terms. 2 plus 3 is 5. 9i plus 7i is positive 16i. Okay, same thing here. I'm adding, so I have 12 plus 2i. And I'm adding a 7 and adding a 3i. Combine like terms, that is 19. 2i plus 3i is 5i. Okay, same with 13. I have 13 plus 9i, and they want me to add, they want me to add a negative 21 and add a 7i. So combine like terms, 13 minus 21 is negative 8. 9i plus 7i is positive 16i. Okay, on here I got an I squared, so I can replace that with negative 1. Negative 8 plus 6i. So this is going to be negative 12.5 plus 3i. And they want me to add a negative 8 and add the 6i. So combining like terms, I'm going to get negative 20.5. 3i plus 6i is 9i. Okay. Alright, and then on this one, we are again adding. So I have 1/2 plus 3/4 I. And I'm adding to that 1/4 plus 1/8 I. But you still have to combine like terms. So I have 1/2 plus 1/4, and then I have my imaginary, so I have plus 3/4 I plus 1/8 I. Well, you can use a calculator or your brain. What color? Purple. Remember my crisscross straight across when you're adding. So criss would be 4, plus, because we're adding, cross would be 2, over straight across would be 8. That's 6 over 8, which reduces down to, by 2, 3/4. There's my real. Now I got to do my imaginaries. My imaginary, criss would be 24, plus cross would be 4, over straight across would be 32. That's 28 over 32, which would reduce down I, and that would reduce down to 7 over 8i. Okay? Alright. 16, now we're multiplying. So I have 2 times 3 is 6. 2 times 7i is 14i. 9i times 3 is positive 27i. And 9i times 7i is positive 63i squared. Combine like terms and replace I squared. I get 6 plus 41i plus 63 times negative 1. That gives me 6 plus 41i minus 63. Combine like terms and I get negative 57 plus 41i. Okay. For 17, we're distributing. 12 times 7 is 84. 12 times a positive 3i is positive 36i. Positive 2i times 7 is positive 14i. Positive 2i times positive 3i is positive 6i squared. Combine i's, replace I squared, I get 84 plus 50i plus 6 times negative 1. 84 plus 50i minus 6. That gives me 78 plus 50i. Alright, and 18. 13 times negative 4 is negative 52. 13 times I is positive 13i. Positive 9i times negative 4 is negative 36i. And positive 9i times I is positive 9i squared. Combine like terms and replace I squared. I have negative 52 minus 23i plus 9 times negative 1. That gives me negative 52 minus 23i minus 9, which gives me negative 61 minus 23i. Okay? Alright, if we do this one, I'm going to distribute. So I have half of negative 8 would be negative 4. Half of 6i would be positive 3i. 3i times negative 8 is negative 24i. 3i times positive 6i is positive 18i squared. So I'm going to combine like terms and replace I squared. I have negative 4 minus 21i plus 18 times negative 1. So negative 4 minus 21i minus 18, combine like terms, and I get negative 22 minus 21i. Okay? On 20, I know you don't like fractions. They're not that bad. They're small. So we're going to distribute. I have 1/2 times 1/4 plus 1/2 times 2/3 I. Then we have positive 3/4 I times 1/4 and plus 3/4 I times 2/3 I. Multiplying is easy. It's just adding and subtracting fractions that are a pain. Alright, when you multiply, you go straight across the top, straight across the bottom. So that's 1/8. That's going to be 2/16i. This is going to be 3/16i. And this is going to be 6/12i squared. Alright, so what I can do now is I'm going to reduce those fractions. So I have 1/8 plus 1/3 I plus 3/16 plus, that reduces to 1/2 times negative 1. So I have, if I put these in order, I have 1/8 minus 1/2, and then I have plus 1/3 plus 3/16 i's. Okay, so if I do my crisscross straight across thing, criss would be 2, minus, because I'm subtracting, cross would be 8, over straight across would be 16. That gives me negative 6/16, which gives me negative 3/8. Okay, and then if I do this, criss would be 1 times 16 is 16, plus 3 times 3 would be 9, all over, straight across, 3 times 16 would be 48. So that gives me that gives me 25 over 48i, and I can't reduce that, so 25 over 48i, and that will be my solution. Alright, on 22, we cannot divide by I, so we have to rationalize. So I'm going to multiply the top and the bottom by the conjugate of the bottom, which is going to be negative 2 minus 6i. On top, I have 5 times negative 2 would be negative 10. 5 times negative 6i would be negative 30i. There's the top. On bottom, I'm going to have negative 2 times negative 2 is positive 4. Negative 2 times negative 6i is positive 12i. Positive 6i, oops, change color, sorry. Positive 6i times negative 2 is negative 12i. Positive 6i times negative 6i is negative 36i squared. Combine i's, replace I squared, and I'm going to get 4, oh those cancel because they're conjugates, duh, minus 36 times negative 1, which gives me 4 plus 36, which gives me 40 on the bottom. And I'm done, except for I can reduce everything by 10, so I'd have negative 1 minus 3i all over 4. Alright, again, this is 2 minus 0.5i divided by 1 plus 0.5i. So we're going to multiply the top and the bottom by the conjugate of the bottom, which would be 1 minus 0.5i. So make that a minus. Okay, I hate it when they write it sideways. Alright, so on top, I'm going to distribute. I get 2 times 1 is 2. Half of 2 times I would be negative 1i. And then negative 0.5i times 1 would be negative 0.5i. And negative 0.5i times negative 0.5i would be positive 0.25i squared. Combine i's and clean up I squared. I get 2 minus 1.5i plus 0.25 times negative 1. That's going to give me 2 minus 1.5i minus 0.25. If I take 2 minus 0.25, I get 1.75 minus 1.5i. There's my top. Okay, on bottom, if I distribute, I get 1 times 1 is 1. 1 times negative 0.5i is negative 0.5i. Positive 0.5i times 1 is positive 0.5 times I, not 1, sorry. And then a positive 0.5i times a negative 0.5i is negative 0.25 times negative 1. Because I squared. Alright, so now if I clean it up and replace I squared, the middles cancel because I was doing conjugates, and I get 1 minus 0.25 times negative 1. That gives me 1 plus 0.25, which makes my bottom 1.25. And there you go. Alright, on 24, I'm going to multiply the top and the bottom by the conjugate of the bottom, which is 9 minus 5i. Alright. On top, I'm going to have negative 7 times 9 is negative 63. Negative 7 times negative 5i is positive 35i. Positive 2i times 9 is positive 18i. Positive 2i times negative 5i is negative 10i squared. Combine i's and replace I squared, and I get negative 63 plus 53i minus 10 times negative 1. That's negative 63 plus 53i plus 10. Combine like terms, and on top I get negative 53 plus 53i. And there's my top. Okay, on bottom, I have 9 times 9 is 81. I have 9 times negative 5i is negative 45i. I have 5i times 9 is positive 45i. Ugh. And positive 5i times negative 5i is negative 25i squared. I'm multiplying conjugates, so the centers cancel, and I replace I squared, which gives me 81 minus 25 times negative 1. OMG. Sorry, I don't know why this thing keeps flipping on me. Which gives me 81 plus 25, which gives me 106 for my denominator. And I am done. Alright. You try one, hit pause, come back when you're ready. And hopefully you got A. They want me to do, first of all, I never work a problem with a negative under a radical, so I always rewrite it first. That's going to be minus I square roots of 25. And then I inside parentheses first, square root of 25 is 5. So I have 6 minus 5i inside. Now distribute my negative 3 times 6 is negative 18 times negative 5i is positive 15i. Okay? Try this one, hit pause, come back when you're ready. And hopefully you got J. They want the sum of these two complex numbers, so combine like terms. 5 plus negative 3 is 2. Negative 2i plus 7i is positive 5i. Try this one, hit pause, come back when you're ready. And hopefully you got E. Alright, it wants us to use the quadratic formula to find the roots. Well, in this case, A would be 1, B would be 0, because there's no x term, and C would be 4. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we plug our numbers in, b is 0, a is 1, and c is 4. So that gives me x equals negative 0, which doesn't make any sense, so 0 plus or minus the square root. That's 0 plus 16 is 16 over 2, except that's negative 16. So that's plus or minus 4i over 2. And that is plus or minus 2i. Okay? Alright, try this one. Hit pause, come back when you're ready. And hopefully you got G. Alright, the quadratic equations whose roots, when they give you roots, they're telling you what x equals. So they're telling me that x equals 3i and that x equals negative 3i. You're kind of going backwards. You have the answers and they basically want the equation that factored into that. Well, if you back up and we go backwards, before we knew what x was, these were on the other side. So minus 3i. This would be x minus 3i equals 0. Add 3i. And this one would be x plus 3i equals 0. And before we set them to 0, they were a product. They had the zero product property. So it was x minus 3i times x plus 3i equals 0. And now finally, to get back to my equation, I FOIL it out. X times x is x squared. X times 3i is 3xi. Negative 3i times x is negative 3xi. Negative 3i times positive 3i is negative 9i squared. Alright, these cancel out because they're conjugates. And I have x squared minus 9 times negative 1 equals 0, which gives me x squared plus 9 equals 0. Okay? Last one. Hit pause. Come back when you're ready. Alright, so it says use the quadratic formula. Well, this says A is 1, B is negative 6, and C is 10. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I plug in my numbers. B is negative 6. A is So let's mix up my colors. A is 1 and C is 10. So I have positive 6 plus or minus. I typed that in. I got negative 4 all over 2. Okay, that's going to be x equals 6 plus or minus 2i all over 2. I can reduce everything by 2. 2 goes into 6, 3 goes into 2 once, goes into 2 once. So x equals 3 plus or minus 5. Alright, good job. We will see you next time for day 8.